Bismillahirrahmanirrahim. Next theorem, let the set consists the element v1, v2, vn of the vector space V over the field F is the basis of the vector space V over the field F. Pi 1, pi 2, pi n be the dual basis of the vector of the dual space of the vector space V over the field F. Then for any vector V of the vector space V, V can be written as a linear combination of pi 1 v1 plus pi 2 v2 plus up to so on pi n vn. And for any linear functional psi contained in the dual space of the vector space V over the field F, psi is equal to psi v1 pi 1 psi v2 pi 2 plus up to so on psi vn pi n. Suppose V is an element of the vector space V over the field F can be written as a linear combination of its basis vector v1 up to vn using the scalar a1 a2 up to an, that is a1 v1 plus a2 v2 plus up to so on an vn is equal to v. Apply pi 1 on both sides of this equality. We have pi v is equal to pi a1 v1 plus a2 v2 plus up to so on an vn. Pi is a linear function from the vector space V to on the field F of the vector space V. Therefore, it satisfies the condition of the linear transformation, which is also equal to a1 pi 1 v1 gamma a2 pi 1 v2 plus up to so on an pi a1 vn. As according to our previous theorem, pi I vj is equal to 1 when I is equal to j and 0 when I is not equal to j. There is pi 1 v1, the result of pi 1 v1 is equal to 1, and the result of pi 1 v2 according to this definition is equal to 0 plus up to so on. The result of pi 1 vn is also equal to 0. After the simplification we get a1, that is pi 1 v is equal to a1. Similarly, for I is equal to 2 3 up to n, apply pi 2 phi 3 phi 4 up to phi n, that is in the generalized form phi I v is equal to pi I a1 v1 plus a2 v2 plus up to so on ai vi plus up to so on an vn. Apply pi I on both sides of this equality. We have phi I v is equal to a1 pi I v1 gamma a2 phi I v2 gamma so on ai pi I vi gamma so on gamma an pi I vn. That is the according to the above definition, the I is not equal to j, therefore the result of pi I v1 is equal to 0. In this case I is not equal to j, therefore the result of pi I v2 is also equal to 0 plus up to so on. I in this case I is equal to j, therefore the result of pi I vi is equal to 1 plus up to so on. The result of pi I vn is also equal to 0. After the simplification we get phi I v is equal to ai, that for I is equal to 2 3 up to n. That is when I is equal to 1, then phi 1 v is equal to a1. When I is equal to 2, then phi 2 v is equal to a2. When I is equal to 3, then phi 2 v is equal to a3, and so on. When I is equal to n, then phi n v is equal to an. Now substitute the value of a1 a2 an up to an, which are the element of the field, and phi 1 v phi 2 v up to so on up to phi 3 v up to so on phi n v are also the element of the field. That is the pi 1 pi 2 up to pi n are linear functional. This is a linear transformation from the vector space V on the field. Therefore, replace a1 by pi 1 v, a2 by pi 2 by pi 2 v, and so on an by pi n v in the above equation. In equation number 1 we have v is equal to, equation 1 implies v is equal to replace a1 by pi 1 v v1 plus replace a2 by pi 2 v multiply by v2 plus up to so on, replace an by pi n v vn. Apply the linear function psi on both sides of this equality. We have psi of v is equal to sine of phi 1 v v1 plus pi 2 v v2 plus up to so on pi n v vn, where pi 1 v pi 2 v pi n v are the element of the field. is each element pi 1v, that is pi 1, pi 2, pi up to pi n are linear functions. Therefore, the image of each element of v under the linear functional pi 1, pi 2 up to pi n is an element of the field. Therefore, pi 1v is an element of the field, pi 2v is also an element of the field, and so on. That is, pi 1v, pi 2v up to pi nv are the scalars. Now, which is also equal to pi 1 psi v1 gamma, apply pi on both sides. We have pi 1 v psi of v1 plus pi 2v is a scalar, therefore which is also equal to pi 2v psi of v2 plus up to so on. Pi nv is also an element of the field, which is equal to plus anv psi of vn. Now, which is also equal to pi 1 psi of v1 plus pi 2 psi of v2 plus up to so on, pi n psi of vn v, where v is common in each term. Cancel v with v, that is the image of the v under the under psi and the image of the same element v under this linear combination of the elements psi. The psi is an element of the dual space, and pi 1, pi 2 up to pi n are also the element of the dual space of the vector space V over the field F. So the image of V under this linear combination and the image of V under psi are the same. That is, in this case, the action of psi and this linear combination are equal. That is, psi is equal to psi v1 phi 1 plus psi v2 pi 2 plus up to so on psi vn pi n, which is our required result.